How many people started off with the program that I wrote last time, like a week ago? Okay, how was it? Was it kind of easy to do? Okay, so that was the intention. Okay, this was not intended to be a difficult homework assignment. It was supposed to be just a conversion from using scanf to cin. Okay, and the emphasis was not really so much the logic of error handling, because we covered that in the previous homework assignment. The focus of this homework assignment is really just to use the concept of cin and other kind of attributes of cin in place of scanf. So what we'll do is we'll start with the program we did last time. And I guess I can start from scratch, just so that we don't use any existing code. And it's usually not a bad idea to start from scratch, just so that I can explain it again to this class from scratch. Okay. So the one that we had before looked kind of like this. We use a standard io.h, stdio.h. And I think I explained this last time. It doesn't hurt to explain it again. The pound include line of a C or C++ program brings in what we call a header file. A header file contains prototype definitions so that the compiler knows what scanf is and what printf is. So when we actually make those function calls, the compiler can check whether we pass the right number and the right kind of parameters or not. So that is the reason why we have to do a pound include of a header file when we use particular functions. The main program is pretty simple. We have several variables that we need to define. With C++, you can define variables or declare variables as you go along. There's no need to put all the definitions all the way to the top of a block of code. With C, you have to put all the definitions at the beginning of the block of code. It's still kind of weird, huh, listening to the voice coming from all directions. I mean, I can turn it off. I mean, that's okay with me.
I'm fine.
You okay? I'm good? Okay.
I'm just curious how it'll turn out on the video.
I think it'll be okay, because I don't think there's enough of a delay, me versus the speaker, to actually cause any particular issue. Let me just double check that the channel is on. Okay, otherwise it's all going to be useless, right? Yeah. All pointless.
Moot.
All right, so we have one variable for the threshold and one variable for the maximum number of entries. And I'll just do the print max number of entries as the prompt of the first number. And for this one, we don't need to do any type of error checking, so just scanf is fine. We read it into max entries, and then we prompt for the second one, which is just the threshold. Sorry? Ampersand? Oh, right. Well, let's see what happens when we forget the ampersand, okay? Because it's probably a good idea to kind of intentionally make a mistake, knowing that that is the mistake, and see what the compiler has to say about it. All right. So now we are ready to actually start the loop. Before we start the loop, we need some additional variables. One is the number of entries that we have actually read, and the other one is the sum of everything. And both of these need to be initialized. So num entries has to be initialized to 0. Sum has to be initialized to 0 as well before the loop. And I think last time I used a for loop. This time I'm going to use a while loop. They're pretty much interchangeable. A for loop is really a while loop, except we reposition things a little bit, okay, so that the initialization, the condition, and the post operation are all located at one spot, whereas with the while loop, they're all kind of scattered all over the place. So the while condition will still be pretty much the same thing. While num entries is less than max entries is one condition, and then we use conjunction to link it to the second condition, because we need both conditions to be true to stay in the loop, because if any one of these two conditions is false, we want to get out of the loop. So the second condition is as long as sum is less than threshold, we also want to use this as a reason to stay in the loop. But there's a conjunction that is connecting these two. And inside the main loop, we have a smaller loop, and we need a number x because we are trying to read an integer into an integer variable, and that's the job of x, is to capture the number that we are reading in from standard in or standard input file. So this is the part that gets a little bit tricky because I'm using scanf inside the condition of a while loop, and this part requires a little bit of explaining, just in case we forget the way it works. So with this one, the first thing it does is the innermost part of the expression, which is scanf %d %x. And what it does is it will attempt to read from standard in a base 10 signed integer, and if it does successfully read the number, the value will be put into variable x. But it also has another effect. It returns a value. Scanf returns an integer as a return value. It returns the number of items that it was able to read successfully. In this case, I only asked to read one thing, so the return value can either be a 0, which means we couldn't read anything, including an integer, or a 1, which means we just successfully read an integer into x. Is that part okay? About the return value of scanf. In C and C++, an integer of value non-zero is interpreted as true, and an integer value of 0 is interpreted as false. So that means if scanf returns a 0, not 0 is going to be true and will enter the inner loop. Is that making any sense? And that's exactly what we want to do, because if we cannot read an integer successfully, we want to clear the junk that is preventing us from reading an integer. So that junk is going to be read into a char. In this case, it is the variable junk, which is of character type. Or if you use, int a_t, you can do that as well. It's basically the same thing. And to do that, we have to use another scanf. And this time, I'm not even bothering to check the result of scanf. I'm just assuming it will be able to read it successfully in the junk. And you can see that I'm not even doing anything with junk. All I want to do is to get rid of it. But there's no easy way to get rid of something that I just read using scanf without having to store it somewhere else first. If I ever get out of this loop, in other words, if execution reaches line 25, what does it mean? Exactly. Okay, to get out of the loop, scanf must have returned non-zero. But the only reason why scanf in this case can return a non-zero is because it had just read an integer successfully. So it is time to get out because I just read an integer and it is now currently in variable x. So it's time to add that number to x. It's time to add x to sum. We also need to increment the number of entries by 1 because we have just successfully read another number. So either post-increment is fine, pre-increment is fine, because nobody cares about the value of the expression. All we want is to increase the value of num entries by 1. That's pretty much the entire program. We only got one little thing to do afterwards, which is to print the value of sum. So in this case, it's %d \n for the line feed character, and sum is the one that I want to print. And then we have a return 0 here just to make the C compiler happy. And that's the entire program. Now remember, I did have one error, at least one, because I forgot about the ampersand. So we'll go ahead and compile the program and see how the compiler is going to complain about this. So we'll go ahead and compile with warn all, pedantic, -g, just in case I want to debug it, -o sum.cpp. And it complains actually at 2 places. I forgot about it at 2 different places. No, only one place. It's on line 9. It complains about format %d expects argument of type integer pointer. So it is not integer because of the asterisk after int. It means it is expecting a pointer to an integer, or the address of an integer, if you will. And in this case, argument 2 is of the type int, and these two are not the same. Yes?
why is that only a warning? So what will if it's only a warning, your code compiled, what is it going to store in there?
The reason why this is only a warning and not an error is because officially scanf only tries to enforce the first argument is a string, but it doesn't really specify what the other arguments are supposed to be.
The storing argument, the location, like so the first one, the string, the %D.
Okay, this is a little bit beyond the scope of what we have talked about, but I'm going to give you the actual prototype of scanf. Okay, in other words, how is scanf how is it actually defined? It returns an integer type. Okay, so that part we know. Scanf is the name of the subroutine. The first one is supposed to be a const char pointer, which means it is a pointer to a string or a pointer to an array of characters. But scanf is not supposed to change the format string itself, and that's why it's const. So it's not a problem when you use double quotes. It's automatically a const char array. So that part is okay. So here comes the tricky part. The rest is actually just ... in the prototype definition, which is basically in C and C++. It means it can be anything. It can be a char, can be an integer, can be a structure, can be a pointer to something, can be a void pointer, can be anything. Okay, and that's the whole thing about C and C++ is it allows you to do something like this. And in the past, before GCC or G++ actually has the ability to understand, oh, this is scanf and we have to pass an address instead of an integer, people run into problems all day long because they pass the wrong kind of stuff to scanf. And when they use printf and you pass the wrong thing to printf, it will also print all kinds of gibberish on the screen because it's not the right kind of thing. So the fact that G++ is actually printing a warning message in this case is only because G++ is being a smarty pant and say, oh, you know what? I know something about scanf. I know about the format string. Oh, this %D format string means we are reading into an integer, and as a result, we should have an integer pointer as an argument and not just an integer. So it is not really a part of the C standard or C++ standard in this case. G++ is actually being a smarty pants and say, you know what? I can do a little bit more than what the language specifies. And that's why it is a warning, because it is technically not a violation of type checking rules in terms of C and C++. Okay, it is something in addition to all of that stuff. So what we will do now is to go back and fix the program. Right now that we know what it is expecting an integer pointer, and we're only passing an integer, so we have to fix that. So the way to turn an integer into an integer pointer is simply to take the address of the integer, and that will convert it from an integer into an integer pointer. So we go ahead and recompile the program, run the program, just to make sure that it is still working. So we will give it like 0 gibberish, 0 gibberish, 1 gibberish, 2 gibberish, and another 0. And that should terminate. Even though the sum is only 3, there are 5 numbers already. Okay? So when I press the enter key, it prints 3 as the total, and the program just works fine in this case. I can also do it like so, 5 and 5, but this time I'll give it 1 gibberish, 6 gibberish, 3 gibberish, and 4 gibberish. Okay? So in this case, it should print 7 because it will read 1. Then the sum is 1. It is below the threshold, and we haven't read 5 items yet. And as soon as it reads 6, the sum becomes 7, and it's already exceeding or meeting the threshold, and it should exit because of that reason. And that's exactly what it does. So I'm pretty sure the program is working, and this is basically what we had last time, and I said it's okay to use my code as a starting point, because the whole point of this homework assignment, the one that's due today, is not the error checking logic itself, but the equivalency between scanf and cin features. So that really is the main focus of this assignment. So what I'll do now is I'm going to copy sum.cpp to sin sum.cpp. Yep, go ahead. Yes.
Why, how come you can't just use it normal, like without declaring standard into the service?
Okay, that's a good question. Now this is weird because I can, if I walk around here, I can hear my own voice coming from different speakers. That is weird. So I have no idea how those performers can perform on stage, because you guys know that they have a whole row of speakers that the audience usually cannot see because it's kind of like sunken, on the floor itself. So those people have to listen to themselves, like all day long.
I think they have a special earpiece.
Except for Britney Spears. Yeah.
Just slammed Britney Spears.
Right. And they don't know how to perform, because they don't know how loud they are and so on.
Well, that's why they have an earpiece. So.
But some artists do not actually sing on stage, you just lip sync. So for those people, well, actually for those people, it makes even more sense to have speakers.
Yeah.
They don't need a mic; they just need speakers so they can lip sync to the music, to the actual recording.
Milli Vanilli.
Maybe you should do that. You should
Yeah, I
You
know.
should just play back the audio if we have morning class.
Right, and I
then
can try to
lip
lip sync to it.
it.
I think that's probably harder than actually talking in real time.
It would be hilarious.
Well, the good thing about programming is, there's nothing to argue about, right? I mean, it is what it is. I mean, the C standard or the C++ standard is the way it is. So it's not like, you're on stage and there's somebody else you have to debate with, right? Like politicians. And for some of those, they have a little cue card to remind themselves, who my sponsors are. And that list is going to be like this long, and rows. Okay. Oh, okay, this is one of my sponsors. I better not say something about. All right, so we need to include a different file in this case. So this time it is IO stream without the .h. Okay. So when they transition from C to C++, somewhere along the line, they drop the .h extension. Okay. It's not right away. It's historical. Okay. They just drop the .h at some point in time. And the convention is in C++, most of the header files do not have a .h extension. They still serve about the same purpose though. It is not a good idea. Okay, you can do this, okay, but it's not a good idea. You can do the pound include all you want. That's not a problem. But the use of cout and printf at the same time, or the use of cin and scanf at the same time, is not a good idea. The reason why it's not a good idea is because both libraries are buffered. Okay, when I say buffered, it means when you try to print something, it does not necessarily go to standard out right away. Okay, so the logic of printf may want to wait a little bit before it actually presents the characters to the output stream, okay, to standard output. The same thing applies to cout. So that means if you have cout, printf, kind of in an interleaved manner, the text that is actually being put out to standard output as a file may not follow the same order. If you say printf12, cout AB, and then printf 34, and then cout CD, it may not come out in the same way as it is interleaved in the code. It may come out as 1, 2, 3, 4, and then ABCD, and that would not be cool, because now the output does not match the actual sequencing of the statements. So that's why you don't want to intermix with those two. You either choose one set or the other set, but don't use both at the same time. Printf is an easy one to deal with. We just have to say std cout and then specify the string that we are printing. So for the most part, it's kind of syntactical change. There's no real actual change here. Cin is a little bit trickier, because with cin, you just change the direction of the operator. So instead of a left shift operator on line 8, now we have a right shift operator on line 9, and you say max entries, but without the address of. The reason why on line 9 we don't have the address of anymore is because the parameter the right-hand side of the right shift operator, as far as C in is concerned, oh, forgot to see here, is passed by reference. Anything that is passed by reference, if you just name the variable, it will automatically pass what we call the address of into the subroutine. So that's why in this case we don't need to, we do not specify the ampersand at all. Okay, so once again we have standard out, C out, and here we have C in to threshold, like so. So for the most part, this is really just a syntactical change from the program the way it was before. That's really not a whole lot of changes. So we skip all the way until line 20. So line 20 is a tricky one because the original line 20, which is the way it is right now, is already combining several things into one single statement. Because we are attempting to read an integer and check whether we read an integer in the same expression. So we want to do something like that using C in as well. And it is possible. So the way we do this, I'm going to comment out the first line first, so this way we have a way to contrast the two approaches. So I'm commenting out line 20, the original line 20, and then use line 21 as a replacement. I will first present the solution, and then I'll explain it. That really is the solution, okay? But it is a solution. It's not clear how it works, okay? At least, if I do not explain it, and I think I did last week, okay? I explained how this works, but it doesn't hurt to explain it just at least one more time. The way this works is when you look at this expression here, it's not really just reading from standard in to X. That's not the only thing it does. As an expression, it also has a return value. The return value is not a Boolean, okay? The greater than or the right shift operator returns C in itself as the value of the expression. So that means if I look at this particular parentheses, or the range between the parentheses here, it really is the same thing as C in as a value. Okay, this is the value of the expression. C in is not of Boolean type, and it is not of integer type either. C in is of the type IO stream, or I stream to be exact, an input stream. An input stream is a class. It is not an integer value. It is not a floating point number. It is not a number at all. It is not Boolean either. So now we have a little gap because the negation operator likes to work on a Boolean value. And on the other side, we do not have a Boolean value. So how do we bridge this gap? This gap is bridged because C in as an input stream, as a type, has a type casting operator to convert anything of I stream type, input stream type, into a Boolean. And by doing so, it is now reflecting the Boolean value of a stream is reflecting whether the previous read operation was successful or not. In other words, this is really just C in itself, but in the process of converting it into a Boolean value so that the negation operator can work, it is now reporting whether the previous read operation was successful or not. And what was the previous read operation? We were attempting to read something into X. In other words, this line 21 is truly doing exactly the same thing as line 20. We attempt to read an integer into a variable and reflect back whether the operation was successful or not. If it was not successful, then we'll get into the loop. When we get into the loop, we have the same job to do, to remove quote-unquote junk. And this time, since we are not using scanf, we're going to use C in. When you use C in, it has one kind of nice thing. It is type sensitive. And because junk is of the type char, is a character, when you use the right shift operator on line 25, C in automatically knows that we are reading a character and not an integer. So it will just take whatever character, whatever byte is in in the stream, input stream at the time, and it will put it into junk, the variable. So there's no need to specify %C because the type of the variable on the right-hand side of the right shift operator already indicates how to deal with it. And this is one of the big, huge advantage of using C++ or object-oriented programming. In cisp360, you will learn how to write code corresponding to operators like the right shift operator here, and you can make it sensitive to the type that you're dealing with. So there will be one definition for reading into an integer, there'll be a different definition for reading into a character, and yet another one to read into a string, and so on. Okay? But they're all right shift operators. I'm not going to talk about it here because it really is a topic for cisp400, but this is one of the reasons or one of the advantages of writing programs in C++ instead of regular C. The rest of the program stays about the same except for the printf line. So once again, we'll comment out the original program and say this is using cout, and we have sum, and also the end of line here. Yep, go ahead.
On Moodle, you talked about having to use the function .clear.
Oh yeah, I forgot about it. Sorry. That is something I forgot. Because without the .clear, this becomes an infinite loop. Because every time it tries to read in junk, it's not going to do it. Yep, thank you. So you have to use clear to clear the error status. Because as long as the error status is still on, all further read operation will fail. Thank you. And that's one big difference between scanf and cin is you have to clear the error status flag with cin, but with scanf, it's not like that. Because scanf is forgetful. In a way, it's forgetful because it doesn't maintain the state from the previous time it tried to read something, but cin is an object. Okay, it has its own memory and it can maintain a state. And that's why once it fails, it can remember that, oh, you know what, the last operation has failed. I need somebody to clear that first before I can read anything else. All right, so now that we have this program pretty much all written, let's go ahead and compile and see if it works. So we have sin_sum.cpp, 5 and 5. And we'll do exactly the same thing as last time. 0 gibberish, 0 gibberish, 1 gibberish, 2 gibberish, 0 gibberish, and it works. All right. And that's kind of what I intended, for you guys to do is really just to spot the differences between scanf and cin, printf versus cout. You can maintain the same logic pretty much as the previous program. Yep. Go ahead.
I had a question because in your your text in here where you're talking about using cin, you say that you can just put in cin and then the variable or whatever. So at the top of this, so if we're looking at I don't know, the first one, max entries or whatever. Couldn't you do you have to have the std in front of it, or because it works without it? And I didn't realize that you needed it for the beginning part. I used it in the rest of it, but not at the beginning.
That depends on whether you have using namespace std. If you have this line here, this line 3, then you can just refer to cin, cout, and end line, end l, without having to say std : every single time. The reason why I do not use a standard namespace std is because if you get into a habit of using a namespace, just so they don't have to type the name of the namespace, : that kind of defeats the whole purpose of having namespaces to begin with. So it's a convenience feature. It's not you can use it. Okay, it's just personally I do not like to use something like
I
that.
wasn't sure because when I didn't at the beginning, but then when I went back to your code to try to put in the error checking and stuff, I ended up adding it in, but I wasn't sure what the difference was. So.
Okay. Did you have this line? Did you have a line saying using namespace std?
Yeah, which is why it worked both ways apparently.
Okay. Yep.
Yeah.
Yeah, with this one here, you can always still specify std : : it doesn't cause any problem. But at the same time, if you do not specify std : : and just specify cin, the first thing you will do is to check the non-namespace, which is all the definitions that you have locally. If you cannot find cin defined locally, then it will go through each of the namespaces that you name after using namespace. So if you have this one and then you say using namespace, let's say some kind of gibberish here, that means whatever definition is also in the namespace of ASDF will also be by default be included. So now if a particular name is defined in both namespaces, then you have a problem because the compiler would not know which one you're referring to. And that was the whole purpose of the namespaces, so that we can separate definitions even though they have the same name, but we can use the namespace to differentiate one from the other.
Okay. Thanks.
Sure. Yep.
For line 21, we should put the cin statement above it and just put the negation operator as cin.
That won't work the same way because if you, let me, I'm just trying to think of how to do this so that it won't mess up the original code and cause confusion. I'll go ahead and do it this way. I'll just open up a new terminal and line up the two together. Okay, there we go. And this one I don't need to actually do anything, I just need to line them up. Okay, so you're talking about replacing this line here with two lines, having the cin std cin to x on one single line all by itself, and then the while will just basically say while not cin like that, right? There's a big difference between these two. The big difference is with this approach here, it will only try to read into an integer once. And that's before we get into the loop. With this approach here, trying to read an integer is a part of the inner loop. So after we clear each junk or each junk character, it will reattempt to read an integer using this logic. But when you use the other logic, it will attempt to read an integer, and it will just be clearing all that junk. But it will only clear one junk character at a time, because it is always successful. Reading a character is always going to be successful unless you're already at the end of file, which is not one of the cases that we have to handle. So that's why it works differently. And if you do it this way, and you fail to read into x, so by the time you exit the loop, you have cleared one junk character, but x will have an uninitialized value, because remember, line 20 has to fail in order for you to clear the one junk character. But because you are not reattempting to read an integer, that means x is still undefined by the time you add one. By the time you add x to sum, it will still be an undefined variable, or it has an undefined value at that time. Is that explanation okay?
Yeah, just gotta think about it a little bit.
Okay. Go ahead.
I did it a little differently. It seemed to work just fine. I did the sin and then the variable, and then right under that I did if parentheses sin, and then I did the rest of the code. I didn't actually do a while statement, but because it was in the other while loop, it seemed to go through without a problem.
Oh, okay. Because you basically say if I did successfully read an integer, go ahead and add that to sum. But if I do not, go back to the beginning of the loop and then go through the whole thing again. Now, if you did it that way, you also have to make sure that the increment of number of entries is also a part of the then branch of the conditional statement, because otherwise it will be incrementing the number of entries even though you're not actually reading a number. So that might be that can be another way to do it. Yep.
I was wondering, if you had used the int8 kind of data type,
Yes.
how does it if it like it doesn't have to, you don't have to like specify what kind you're reading, how does it know that say number 9, which is also just the character itself, right?
That's because the actual definition of int8 underscore t is char.
Okay, so that's what I'm saying. So since technically the key 8 is just a char, right?
Mm-hmm.
How does it specify that, okay, I should take that as the actual integer now instead of
I don't think there is a way to do that. I don't think there's a way to do it because cin does not. Cin only has one way to read into the default integer type. I don't think it has a way to read into a 16-bit integer or an 8-bit integer. That to look it up. Okay, this is what you do to look it up. So what you're asking is something that you can look up with the definition of iStream. So you want to look up C++ iStream, definition, and it gets you to c++.com right away, which is the source for something like that. I don't think the right shift operator is defined as in iStream. It is actually defined in one of the what we call superclass, which is iOS in this case. And then you look up this one. And it's not there either. So it's probably an iOS base. Let's take a look at that. Okay, it's got formatting, it has got to be this one.
It wasn't, the last one said operator, but it had the negation on it. No, so if you go to like, if you go forward, or whatever the last class that we were at had a definition for operator, but it had a negation. That's what we had. Where it says operator, negate.
Okay, but it only has the negation operator, and I don't see the right shift operator. So maybe. There we go. So it is under iStream itself, I just overlooked it. Okay, so these are the things that you can read into. So short is one of those. So if short maps to 16-bit integer, you can deal with it. But you can see that 8-bit integers is not here.
Oh, okay.
A char is here, so let's see, where's the char?
I don't see it.
You don't see it? Let's look at a new standard. Short, long, long, float, double, long.
A short wouldn't count as, no, because a short's 2 bytes.
Short usually maps to a 16-bit integer, so it's not exactly a char either.
So then what ends up happening is basically, if you press a number, that'll get read as a 4-bit, I mean a 4-byte integer, instead of like, so you're saying it doesn't map to a char, which would just be a single byte. It'll map to like the standard, like say a 32-bit integer.
Okay, let me explain it by changing this program. If I make this a short int, it will still work, because this will attempt to read into a short int, and x being a short int is not a problem unless you want to specify a number that is larger than 32,000 or less, well, thereabouts. Okay. So as long as you're dealing with numbers within that range of values that can be represented by a short or 16-bit integer, it will still be okay. Now, it seems like we have a type mismatch here because sum is 32-bit, it's a regular integer, and x is a short integer. But remember what we talked about in type coercing? It will automatically convert the type to match the larger of the two. So x is automatically promoted to a 32-bit integer first, and then the addition happens. So it won't be a problem, in this case. Right. So any other questions with this particular homework assignment? No questions? All right. If there are no questions about this homework assignment, we'll go ahead and get to. Okay. Last time we were talking about scope and the scope and lifespan of variables. We talked about global variables and why we really should not be using any non-const global variables. Const is okay because it remains the same throughout the execution of the entire program, and is typically used to represent values that really should be constant throughout the execution of the program. For instance, gravity in terms of in units of meters per second squared is 9.8 something, and that can be used as a global variable, as a constant global variable, because that's not going to change throughout the program. Unless you're dealing with a space probe that has to go visit different planets, then the G is different. Okay, so there are always exceptions to the case, but assuming your app is always going to be running where G is always 9.8 meters per second squared, then it's okay as a const. We talked about auto local variables, and they're really useful. That is the default storage class for local variables. And for a class like this, I really do not see any need to use the static class. Okay, the introduction of a static class local variable, which is the link next to it, is kind of dangerous. Okay, it's dangerous not because it will cause problems in this class, and that's the exact reason why it is dangerous. Okay, in this class, okay, if you change from the auto storage class to the static storage class for local variables, for the most part, almost all of your subroutines will still function correctly with no problems. However, when you take those functions and you apply those in a different setting, anything that involves ISR, interrupt surface routine, signal processing, or multi-threading, though in those cases, whether you use a static storage class or auto storage class will start to make a difference. Okay? But it's not going to be a syntax problem. In other words, the compiler cannot catch it. The compiler cannot say, oh, you know what, in this particular scenario, you really should be using auto and not static. It doesn't give you a warning. Okay? Because syntactically, they're almost, they can, where you can use auto, you can use static, and vice versa. So syntactically speaking, the compiler cannot do a single thing to see if you're using it correctly. But in terms of actually using it, the worst part about using static when you're not supposed to use it is the symptom is going to be very unpredictable, because then it depends on the timing of interrupts, okay, which is based on external hardware events. And also multi-threading, same thing. Okay, the timing is not always predictable. So that means if you use static instead of auto, your program may not misbehave for a few years and then it crashes. Or it may crash like within a second of you starting the program. And that timing is not predictable, okay, because it depends on a lot of other stuff that is happening out of the control of your program. And then the second part, which is even worse, is the symptom is also going to be different each time, or potentially can be different each time. So when it crashes, or when the program misbehaves, each time it crashes, even though it's coming from the same source of the problem, the symptom can look entirely different each time. And those are the worst type of problem you can deal with, because one, it is not easily reproducible. And when the problem happens again, it does not appear to be the same problem each time. Okay? And in my previous job, I have to deal with stuff like that, so I kind of know this stuff a little bit, having experienced it firsthand. So in this class, I'm going to defer the discussion of static local variables unless we really have a need to use it. Okay, because talking about it without the actual need to use it is going to be leading to problems. So I don't want to talk about it until we have to. I have added 2 files to this particular topic. The first one is Fix This Mess. Fix This Mess is a zip file. You can download the zip file and unzip it. When you unzip the file, the description actually talks about what you're supposed to do with it. It is not a homework assignment. You won't get any points. but I encourage that you do it, okay? Because it is going to help you understand certain concepts of global variables. So when you unzip it, you will have three files. One is incx.cpp, one is decx.cpp, and the last one is main.cpp. So you have to compile each file individually and link them together to become one single application, which doesn't really do a whole lot. It just has one single global variable, one function to increase the value, one function to decrease the value. But it's not going to compile first time, okay? And when it does compile, it may not link correctly. So you have to fix all the problems with compiling and linking to get this program to work. And in the process of doing that, I'm hoping you will learn about static versus non-static global variables. These are not local. And also how to refer to another variable that is not defined in the file. Okay. We talked about all of those concepts last time already, okay, on Monday. So we should have all the knowledge to do all this. This is just kind of more or less a hands-on thing for you guys to do to fix up this particular program. So that's the first one, and then there's a second one, which is Figure This Out. Figure This Out is a program that is already working. Okay, it's basically just factorial, but it's done in a recursive way. So I want you to download this program and just run it. Now, when you run it on the command line, you will see something. Okay, and I want you to go through GDB to kind of examine how it can get it done when it is a recursive subroutine. Okay, so these are the two things that I want you guys to download and just kind of do something. It's an exercise. Okay, there's nothing you have to turn in. It's not a homework assignment. But I think in the process of doing this, it will help you get a better understanding of the content of the material that we have already talked about. So are there any questions about this? No questions? Okay, now we are moving into the main part of today's lecture, now that we only have about half an hour left. It's not bad because I think what we have done is to reinforce concepts that we have been talking about already, and reinforcement is important. So now we're starting to talk about structures in C and C++, okay? Technically speaking, structure or struct is a C feature, but C++ also has support for structs. So this is a really kind of long, boring, text description of what it is. So what I want you to do is to we can do an example first, or we can do an analogy first. Which one do you want to do? An actual C++ sample code, or do you want to just try and talk about the analogy? Sample code? Okay, sample code it is. All right, so we'll go ahead and, yep, go ahead.
Is structure just a class or is it a function for the Java?
A structure is almost the same as a class. With one exception, in a structure, all members are by default public instead of private. So that's the only difference between a struct and a class.
Can you set a structure to be private?
I think so. I think inside the structure you can use private colon to say whatever follows is private. But we're going to talk about struct without references to classes, at least at this point.
Then our structures just used mostly as a defining functions. It's not the same way you define a function in Java.
Say that again?
Would structures mostly be used for creating a function that you might want to call multiple times?
No. Structure has the same purpose as a class is for encapsulation.
Oh,
So it still serves the same purpose. It's just that struct comes from C, and class is an enhancement of that concept. All right. So what we'll do is we'll go ahead and I'm gonna remove the example that I talked about this morning and start from scratch. So.
Roll.
Thank you. So what we're doing is we didn't take roll on the third, so I'm going to change the third to the fifth. That's going to be just the last column. Okay, so what we want to do is to think about how we represent time or date. Okay, so let's just deal with date for now. Okay, how do you represent date as a human being?
Oh, no way.
You're not a human being.
I was gonna say number of milliseconds since January 1st, 1970.
That would be the internal representation. So you're absolutely right. You know, in Unix and also Linux in this case, time is represented by the number of milliseconds since 1970, January 1st, midnight. Okay, that's how a computer keeps track of time internally. Now, it may sound really awkward to us, but it makes a lot of sense. Okay, and oh, you forgot one thing, GMT. Because otherwise it becomes time zone sensitive, right? Because are you talking about Eastern Standard Time or Pacific Standard Time? But when you're only using GMT as the reference point, then there's no confusion whatsoever. You can always convert from GMT to PST, okay? But if you only keep track of local time, then it becomes really confusing. Is that making any sense? Okay. And Windows keeps track of local time. Unix keeps track of GMT. So that kind of tells you something right there. Okay, so internally the computer keeps track of a big, huge, long integer, which is in milliseconds since 1970. But how do we keep track of dates? How do we tell someone, oh, on this date, I have something to do?
Date, I mean, year, month, date.
Year, month, and then day of month, okay, or just days, okay. So that's how we represent, a particular date. So I want to write a program, and the only job of this program is to enter 2 dates, and it will tell me whether the first date is after the second date. That's all I want to do. It's not very complex, right, in terms of logic. But in terms of tedium, this can be a really tedious program. So I'll just go ahead and say, I personally like standard STDIO. That's my personal preference. So I'm going to use it a little bit more than C in and C out. Okay, but now that we know they're kind of the same thing, except they do things differently, it's not a big deal. So in this particular program, inside main, I will have to read what? How many integers do I need to read to compare 2 dates?
You gotta read 3. No, you gotta read
6, right? Well, because 3 for the first date, 3 for the second date. Okay, so I will need to define those things as year 1, or year of the first date, month of the first date, day of the first date, and another set for the second date, right? And then I have a whole bunch of scanf, right? Your printf and scanfs. So now we have your printf, year of date 1. That's the prompt, okay? And then we have scanf. Assuming we are not doing any type of error checking, I'm just going to use a scanf here. Ampersand year 1. And then I do a 2 white line, paste. And then now it's dealing with month, right? And then I can do the same thing here, line 12 to line 13, substitute month with day, and now it's all dealing with dates. Then I make a copy of everything, right? Copy, it's 8, line 8 to line 13, copy to line 14. Oops, one line too many. So line 8 to line 13, copy to line 13 because it's pasting after. So there we go, we have a second set. So now we say line 14 to line 19, change 1 to 2. And now we have a whole bunch of statements that will read in all the different dates, or the components of the 2 dates. Okay, that seems pretty tedious already. Okay, now I want to write a subroutine to do the comparing, because I might need to use the subroutine from different places to compare 2 different dates. Okay. It's not a big deal, right? And let's just say that the subroutine is going to only return a value whether the first date is later, so whether the first one is later than the second one. Okay. How many parameters do we need here? We'll need 6 parameters, right? Because we need 6 integers. Year, month, day of the first date, year, month, day for the second date. All right. Well, it gets a little bit tedious, right? So we have year 1, month 1, okay, integer type. Yeah, we have to say integer, year 1, integer, month 1, integer, day 1, and substitute 1 with 2, get rid of the comma, and that becomes, you know, the argument list of the subroutine. Okay. And we're going to have some code here. That's not even the focus of this discussion. At this point, I have everything read. I need to, you know, call the subroutine, right? So I can say if is date, the first date is later than the second date, blah blah blah. I'm going to fill this in later. We want to print, you know, something that's simple. Okay, we just say printf the first. Okay, I can say date 1 is later than date 2. Okay, that's all I want to do. Okay, the problem is here. So, you know, I'm just going to be doing like, okay, year 1, month 1, day 1, year 2, month 2, day 2. Okay. Now, most of you spot the problem right away, but since I was distracted when I was writing this program, I did not spot the problem right away. Now, it's not an easy one to spot, okay, because, you know, you have been following what I've been doing, and that's why you can follow and actually spot the problem right away. But if you're distracted, this is something that, you know, this is a mistake that can happen, you know, anytime to anyone. And most people will say, but that should not be a big deal because the compiler can catch it. Okay, G++ dash C, you know, let's say I just want to compile without even getting to the executable. It complains and say, oh, too many arguments to function is date later because it's supposed to take 6 integers and not 7. I gave it 1 too many, right? Okay, so I'll go ahead and fix the program. You want 6 integers? I'll give you 6 integers. Maybe the last one is extra. Problem fixed. And you guys will say that, oh, wait. The problem is not fixed, right? But as far as the compiler is concerned, it is fixed, right? Okay, let's give it a try. Compiler says no problem. And why do you think something like this can happen?
You got to keep track of all of those different parameters and variables.
It's just because of the tedium of this particular subroutine. It takes 6 integers. Now, because all 6 of those are actually just integers, I can accidentally pass a year to a month and not notice it. The compiler won't notice either because they're all integers. They're all quote-unquote compatible as far as types are concerned. So we have a problem here because, you know, even though with careful programming this is not a problem, in general, this type of programming makes it easier for people to make mistakes, which is not cool. Okay. All right. So now is a good time for an analogy. Okay. I don't think we have any forms here that I can use, but if you remember the last time you filed an add form, a petition, or a prerequisite challenge form, how many fields do you usually have on the form? I'll give you 2 alternatives. 1 or more than 1. More than 1, very good. So usually with a student form or form that student has to fill in, it will ask you for the first name, last name, student ID, okay, at least these 3. Occasionally it will ask you for your phone number. If you add into a class, it will ask you for the section number of the class, and so on. Okay, now imagine this. Instead of having one piece of paper with all of these fields, imagine I shred and cut up, you know, these forms so that you have little strips of paper instead of one piece of paper. And on the first strip of paper is first name. The second strip of paper is last name. Third strip of paper, student ID. Fourth strip of paper, section number of the class that you're trying to add, and so on. Okay? So now instead of carrying a single piece of paper and you're walking into enrollment services and say, I want to add to this class, you're now walking in with a little pile of strips of paper. Is that okay so far? Is everyone getting the actual imagery of what you have to deal with?
Image, sure.
Yeah.
Rationality, no.
Okay, well, I will explain the rationality later. Okay, now, to make this worse, let's say that when you're walking into the administrative building, you kind of ran into another student and both of you go like that, and then all of these little strips of paper fall to the ground in random orders, okay? Now you have to gather things up and see, okay, is this yours or is that mine? You know, that sort of thing. Is that reminding you of what we have been doing with this program? Little chunks of information and lots of little chunks like that. It's easy to make a mistake, okay? It's easy to pick up the student, not the student ID, but the section number that you are trying to add from the other student and not realize that you have picked up the wrong one because they all look about the same. So it would be nice if we can pack things together, like having a normal form as a sheet of paper with multiple fields. So we want to do the same thing with programming. In programming, this is the job of structures. Okay? The concept of a structure or records in Pascal is to do exactly that. So we'll start with the definition of a form, and then we'll talk about how to use a form. Okay? So to define a form, which is the template, okay, this is really just the template. You start with the word struct, and then you specify the name of the template itself. So this is equivalent to the name of the form. This is add form, okay? And then you specify what is in an add form, or in this case, what is in a date. So in a date, we have a year. In a date, we have a month. And in a date, we have a day of month, or I can just use a DOM in this case. Okay, so that's a template. It is a template that you don't want to mess around with, because this is what you use to create the actual forms that will be used to store information. So this is just a template. But in a way, this is also our own type. In other words, in addition to char, int, and all the other built-in types, I have now a new type. I have a type called date with an uppercase D, and that is a convention. When you define your own type, you start with you start that name with an uppercase character. So in this case, we start with uppercase D because it is the name of a type and not a regular. It's not a variable. Okay. So in this program, now we can start to do something that is a little bit more handy. So we can now start to say, you know what, this program needs to deal with two different dates. And this is how we make the two variables, each one being a date itself. So we can say D1 is a date and D2 is a date. And now we don't need those little things anymore. Are we doing okay so far with this code? Okay. Hold on a second here. I have no idea what is date, D-A-T-E, and how it relates to D1 and D2. Okay, this is the time for a second analogy, and this one you guys will like. It's about cookies. Date on line 3 is a cookie cutter. This is our cookie cutter, which means this is a template, okay? It defines the shape of things that you can make with it. So if I have 20,000 cookie cutters at home, does it imply that I have a lot of cookie dough at home? No, cookie cutters is just what you use to make cookies. So it doesn't imply that I have been using any cookie dough at all, okay? I can have a lot of cookie cutters and not use up a single gram of cookie dough because I'm not making any cookies. Is that making any sense? So the same thing goes with type definition. I can end up with like a gazillion of these struct definitions, but as long as I'm not making anything out of these cookie cutters, there's no space consumed in the program. It doesn't use up any space. It does not use up any memory. It does not use up any disk space. It's just sitting there, being ready to make things out of it. Okay. What about these two? What about if date is a cookie cutter, what is D1 and D2? They're cookies, exactly. Well, so we're getting to the cookies, the good part, right? So D1 and D2 are cookies. In other words, they are things that conform to a certain shape, and the shape is defined by date in this case. Is that okay? Now, this analogy can be pushed in two different directions. One is memory consumption. When you start to make cookies, you will be consuming cookie dough, right? So using one single cookie cutter, if I have a gazillion of these variables, I'll be using a lot of resources because each variable takes up memory resources. Is that okay so far? Now there's another direction I can push this analogy, and I have to erase this part here because it's kind of giving you an idea of what I want to talk about. Okay. Let's look at addition as an operator. Okay. As an operator, what can we put on either side of addition? Anything that has a numerical value. Okay. It cannot mean anything. It can, like for instance, C in on one side doesn't seem to make any sense, right? I mean, why are you adding standard input file to something else? So that really does not make any sense. So we can have 5 and 3 here. But in some cases, some certain things don't really work out in addition. Like if I have D1 on one side and D1 on the D2 on the other side, and those are dates, those are both dates. It doesn't make any sense. How do I add 2 dates? I don't know. Do we just add the years together, add the months together, or add the dates together, or what? I mean, nobody tells me, right? It's not defined. So you can kind of imagine with anything that you can do with values, at least in C and C++, which are both strongly typed languages. Whenever you have an operator, you can imagine the operator has 2 slots, and the slots have shapes. So in this case, let's just say that the addition operator has a shape like this. Integers, let's say just 5, has a shape that looks like this. So now you can see that 5 as an integer can fit into this slot over here, and 3, let's say 3 is an integer here, it has exactly the same shape, can fit into this side here. So once again, the cookie cutter analogy is really helpful because every time you cut out a cookie using the int cookie cutter, it has this particular shape. And what you can do with those cookies is that you can plug those cookies into the addition operator, and it will fit. Is that okay? Now, ints are very small cookies. I mean, there are bigger cookies out there. Like date is a bigger cookie. So with date, you can kind of imagine date has a very special shape to it. So we'll just kind of imagine that date has a shape that looks like this. Okay, this is D1. D1 as a cookie has a shape like this because date as a cookie cutter has this shape. Can I plug D1 onto the left-hand side of addition? The shape doesn't match. And that's what types do in C and C++. A type is basically a tag of a variable, and it tells you where it fits and where it does not fit. Is that okay so far? And by defining date over here, I am defining a new cookie cutter, and it has a different shape from int, from anything else. So every time you use a struct, it has quote unquote a different shape. Are we still doing okay so far with this code? Is that okay? All right. So if this is okay, we can now change the prototype of its date later. So instead of passing like 6 parameters, which is really confusing and easy to make a mistake, this time I just need to give it 2 dates, right? So I can say, oh, the first parameter D1 is a date. The second parameter D2 is also a date. Now I only have 2 parameters. Is that making sense? Okay. And to make this program, I'm not sure whether you guys realize or not, but this chunk of code took a lot of copy, paste, and modify. Right? I mean, I did it quickly using tricks in Vim and stuff like that, but it is still copy, paste, and modify, and I did it quite a few times. For a class like this, and for all of your future programming classes, every time you copy, paste, and modify, you really need to ask yourself, is there a better way to do it? Because every time you copy, paste, and modify, if you forget the last step, which is modify, then you might end up introducing a bug in your program that is difficult to catch. The problem is not introducing bugs. I mean, we do, introduce bugs into programs, make mistakes all day long. The question is, how quickly can you catch those problems? And copy, paste, and modify, and if you miss the modify part, those bugs are difficult to catch. They're really kind of obscure. For instance, when I do the copy, paste, and modify stuff, what if I forget to change this one to date 2, and I just retain the original value of date 1, because I didn't use the VI feature to do it. I do everything by hand, I just missed this one. The compiler would complain? No. The compiler would not complain.
No, it wouldn't complain, but you would end up entering in day 1 twice and have nothing for day 2.
Which is bad, because first it will overwrite the actual day of date 1, and then 2, date 2 remains uninitialized. So it's going to introduce those problems. But until I actually make use of day 1 and day 2, the problem won't surface. I cannot tell there is a problem until I make use of the day 1 and day 2. So those are the problems associated with using many different variables and rely on copy, paste, and modify as an approach to say, oh, I want to do something kind of like what I did earlier, but this time with a slight difference. So how do we do something without using something like that? Subroutine is one, okay, but using structure is certainly another way. So now we can go ahead and define, I'll just call this read date as a subroutine. And now I can say, oh, we're going to read into a particular parameter, which is a date. And this time I also have to be careful, because I want to specify this is passed by reference. So D is the name of the parameter. It is passed by reference. And in here, even though I only have one single parameter, this parameter is a structure. And as a structure, it has multiple members or different parts to it. And in here, I can now say, oh, you know what? I'm going to deal with all these different parts. So I'm going to do what I said is not a good idea, which is copy and paste. But this time, instead of reading into year 1, I can now read into d.year, which is representing d.year. The dot is basically apostrophe s. Okay, it is the year component of parameter d. How do we know parameter d has a year component? It is a struct date. Okay, it is of the type struct date, and as a date structure, it has a year. So that's why we can refer to that. And now I can do the same thing with the other two members. So we have d.month, and then we have d dot day, D-O-M, date of month, like so. So with this, I no longer need all of this junk here anymore, right? Because now I can take this all out and replace it with two single function calls. The first one is going to be read date D1, read date D2. You might need to have a prompt that say, okay, I'm reading date 1 now, I'm reading date 2 now. But you can see the code is now a whole lot cleaner. And also because I'm using D1 and D2 as dates, and also we changed the function, now we can say we are comparing D1 to D2. And you can kind of see how the program looks a lot cleaner this time, and it is harder to make a simple mistake because we don't need to copy and paste anymore. So this is actually a very good lead into modular programming. which is something that we will talk about later, because the next topic is library and modules or modular programming, and this definitely relates to that. Okay, if you have one thing to remember other than cookies, from today's lecture, it has to do with copy. Every time you copy, paste, and modify, ask yourself, is there a better way to do it? Because there's usually a better way to do it. All right, that concludes this class, and I can go home and check the audio quality of the recording, because I've been worrying the whole time.